Let's look at how to graph a logarithmic function. Now when we're graphing a logarithmic function, we want to be already comfortable with what logarithms mean and how we can evaluate a log of a base of a quantity. And so if you're not quite comfortable with that yet, you might want to go to one of the earlier segments that defines the logarithmic function or the ones that just works out examples of finding values of logarithmic expressions, where your argument is like a perfect power of your base. But for this one, we want to just graph y equal log base 2 of x. Now what we want to do here, or can do, is actually just make a table of values. And what I want to do is realize that I'm putting my values of x in an argument where I have log base 2 acting on that. So I want to pick values of x that are perfect powers of 2. Because remember, logarithms are the exponents that you put on the base to create these values. Well, if I'm picking perfect powers of 2, it's easier for me to figure out what exponents I would put on 2 to create that. So for my input, I'm going to put in values that are powers of 2. Well, I know 2 is a power of 2. 4 is a power of 2. 8 is a power of 2. 16 is a power of 2. 1 is actually a power of 2. And 1/2 is a power of 2. 1/4 and 1/16. So each of those values are powers of 2. Now we're going to go with the easier ones first, the ones that are my whole numbers on the arguments I put in, and then we'll go to putting in the fractional values. So let's first just look at if we had an input of 2. Well, log base 2, that's the one we're graphing, of my input of 2, where the x is sitting, is what exponent do you put on 2 to create the value of 2? Well, I put an exponent of 1 on 2 to get the value of 2. Log base 2 of 4. What exponent do you put on 2 to create 4? Well, 2 squared is how I get 4, so it's an exponent of 2. For log base 2 of 8, what exponent do you put on 2 to create 8? Well, 2 cubed is how I get 8, so an exponent of 3. Log base 2 of 16, the exponent I put on 2 to get 16 is 4, because 2 to the 4th is 16. Now what about log base 2 of 1? What exponent do I put on 2 to get 1? Well, any non-zero number to the 0 power is 1, so the exponent I put on 2 to get 1 is an exponent of 0. What exponent will I put on 2 to create the value 1/2? Well, that would be an exponent of -1. If I have log base 2 of 1/4, what exponent I put on 2 to create the value 1/4? Well, -2. And then log base 2 of 1/16, what exponent do I put on 2 to create the value 1/16? That's -4. Because 2 to the -4 would be 1 over 2 to the 4th, which would be my 1/16. So here's a lot of different values that we can now plot to draw our graph. So I have 1, 0, we'll start there. So if I go right 1, 0, up or down, there's my 1, 0. Then 2, 1, right 2, up 1. And then 4, 2, right 1, 2, 3, 4, up 2. 8, 3, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And 16, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4. There. Now these other fractional values, I have 1/2, -1. So I'm going to go right 1/2 and down 1 for that dot. 1/4, -2. I'm going to go right 1/4 and down 2 to draw this dot. And then 1/16, -4. Right 1/16 is right just a tiny little bit, and then down 4, 1, 2, 3, 4 to draw that dot. So when I look at each of my values here and I start to graph this, we notice that we get closer and closer to the y-axis as my inputs are smaller values, and these are going down to my negative infinity. So I have the y-axis as a vertical asymptote, and I just go through these values that I've already plotted, and we get our graph of y equals log base 2 of x.